Hi Brian, great to see you here at Embedded World 2023. Now, what's been happening at Qorvo? You've got the power application controllers, the PAC system in place for quite a while now, focused on motor control.
Yeah.
And I see you've started to branch out into another aspect of, which is very important to motor controlled applications. So what's new?
Yeah, we're super excited here at Embedded World 2023. We're announcing a brand new product family for us at Qorvo. As you said, for the last 10 years, we've been really investing heavily in that trend for brushless DC motors. But in all those applications that are moving to brushless DC, you see battery power, requirements that are all through there. So, our customers are asking us, hey, you're experts on the motor control side and intelligent motor control, why not help us with the intelligent battery management? So what we've announced is this new product called the PAC 22140 and the PAC 25140. It's the industry's first intelligent, fully integrated 10-cell to 20-cell battery management part. Pairs up perfectly with our motor control solution, so now we can really be that complete solution provider for anybody doing a motor control application that's battery powered.
So in that, in the motor control application, you've got a sort of split architecture. You've got a digital side and an analog side, and that analog side is dedicated to motors. How does the PAC 20000 series look? Is it similar?
Yeah, so I think in a lot of these applications, you need that intelligent digital core, but then you also need that high performance, high voltage analog capability as well to do these power management or motor control and battery management type applications. So on the digital side, we use a industry standard ARM Cortex M0 or M4F. We offer that both on the motor control side as well as on the battery management products. But then on the analog side, it's critical in the motor control front that you have motor drivers that can range from 40 volts all the way up to 600 volts. So that's not going to be in a digital process, that's going to be in an analog process to hit that high voltage. And then same thing on the battery powered side, you see battery packs now moving from 40 volts to 60 volts to even 80 volt battery packs. And so with this new family of battery management solutions, we've actually developed the analog portion of that in a 160 volt process node. So it gives tons of headroom over an 80 volt battery pack, for example. So yeah, having that digital intelligence is key, but then having that high voltage analog for the power management side, and we're trying to bring both pieces of the puzzle to customers. So.
Now, a lot of different applications are going electric. We're moving away from gas or ICE powered equipment like lawnmowers and even like small diggers and things like that. Also in the small hand tool space, we're seeing a lot of things moving away from cable to battery powered. What sort of application spaces are you targeting with this battery management system?
Yeah, so really you see a broad range of industrial type products, whether it's power tools or e-mobility, but even kind of getting away from just motor control, there's energy storage type applications and stuff too that have larger battery packs in it. So I would say our focus is really on broad industrial type applications, and like I said, we've been playing in that area on the motor control side for many years in a broad range of applications, like I said, from tools to e-mobility, and we expect that that's only going to kind of proliferate to many more applications over time.
Now you said on the digital side you've got a microcontroller in there, but how do engineers and engineering teams get started? Is there like some fixed software and that's what you use and they've got some knobs that they can tune to their application, or is it fully programmable?
Well, it's a number of different things, but it is fully programmable, both on the motor and the battery management side. And the nice thing is, since it's a common digital core between both platforms, once customers build the tool or get the tool set up and everything, all the example code and everything, they really get used to one common core they can use across both the motor control and the battery management side. At the same time, we're building ecosystems with development kits, GUIs that they can configure the device, so we give them a lot of great starting points so that the out-of-the-box experience is nice and easy to get started. But then when they want to add their own IP, the once again, fully programmable architecture, that they can really differentiate their solution however they feel fit as well.
So we've got a new product here on the Embedded World Trade Fair stand. Is this then immediately available for people to get started, or when's it sort of going to be available for integration in new designs?
So we're already in production on our M0 based platform, so they can go place orders today for evaluation kits and samples. On our M4F platform, we're sampling that as well today, and we'll be in production in April, so we're very soon. So it's all readily available, development kits, samples, data sheets, all the documentation and collateral. So we're excited to help customers get started.
Fantastic. Well, thanks ever so much for taking us through the design today and the new product. Wish you all the success for it, and we look forward to seeing what comes up next year.
Thanks a lot. Thanks for the time. Appreciate it.
Hi Stephen, great to see you here at the Qorvo stand. Now we've just been talking to Brian about the battery management system, and you're the guy that's going to be able to guide me a little bit more through this particular demo and explain how it all comes together.
Okay, certainly. So what we're demonstrating here today is actually our PAC 22140, which is an SoC that is designed for the battery management system. And so here you see a diagram illustrating all the circuitry around that with 20 cells and the PAC plus, PAC minus input. And so this device has also the control of the FETs. And that's this board here that is the evaluation board for the PAC 22140. And I'll just bring up another picture here, which is highlighting what's inside this demo box. So we have the battery management EVK here, and then we also have a supercap board which acts as our battery, and we're using supercaps for safety reasons rather than having the lithium ion battery that would normally be controlled here.
Yeah.
Okay, and so we'll charge up the supercap, our battery is, if you will, and then once we've got the supercap charged, using the BMS to control all the charging, then we'll turn off the charger and we'll connect to the motor, our motor control EVK.
Yeah.
In this case, it's a PAC 5532, which goes up to an ABS max of 160 volts. And this is good for garden tool applications, as is the battery management. So it makes great companion for each other there.
Yeah.
And so that's what we have here inside the box. And then with the motor control EVK, we'll be controlling this motor and doing brushless DC motor control. In this case, using field-oriented control algorithms, which run on the MCU in the motor control chip.
So I was going to ask, with the battery management system, cell balancing is an important aspect of taking care of the cells and in extending the lifetime of the entire battery pack. How much of that is done autonomously? Is any of it done autonomously through the analog side, or is it all controlled from the digital side and monitored from there?
It's all controlled inside the MCU that's communicating with the analog front end. And so the firmware running on the device then controls which cells are being balanced at any given time, based on which ones are too high a voltage, and so that'll reduce the voltage to keep them in balance. And that's what you see here on the screen is the ones in orange are being balanced right now, and the other ones are not. And so it's selecting the higher ones and reducing the voltage.
Now, batteries are obviously can be dangerous if they're not looked after, not charged correctly. Overheating is a challenge. How is that handled in this SoC design?
Right. So inside the chip, we have various protections that monitor the current and do overcurrent protection, but also monitoring the cell voltages and the total battery pack voltage, to ensure that all of the voltages are within the right range and shut things down if they're getting too low or too high.
Yeah. And in a typical application, you mentioned garden tools, for example, those battery packs, do they communicate with the main device over an interface typically, or how do they sort of explain, I'm connected? Is there digital interfacing involved?
Yes, so in our battery management chip here, the PAC 22140, we have various communication interfaces like I2C, UART, SPI, and these are the key ones used. In the PAC 25140, which has a Cortex M4F, we also have CAN, which is popular for e-bike applications and automotive applications.
Great. Well, thanks ever so much for taking us through the demo. It's really nice to see it in action here. Thank you.
Okay.